Fascinated by space? You're in the right place. Like, subscribe, and hit the bell to join our cosmic adventures. Don't miss the next launch into the stars. Now buckle up. Let's blast off into the cosmos.
Have you ever heard a piece of news that sounds like it came straight out of a science fiction movie? Well, I have some for you today. Scientists have discovered something truly amazing about our home planet. This summer, in July and August of 2025, the Earth is actually spinning just a little bit faster than usual. It's like our planet is in a tiny bit of a hurry. This isn't something you'll be able to feel as you walk around or play outside. You won't get dizzy, and your days won't suddenly feel shorter. The change is so incredibly small that only super-sensitive scientific instruments can detect it. But it's a fascinating puzzle for us to explore together. So, how small is this change? We're talking about milliseconds, which are thousandths of a second. Imagine trying to blink as fast as you can. A millisecond is much, much faster than that. Even though we can't feel this speed up, it's a big deal for the scientists who keep track of our planet's every move. It's their job to measure these tiny shifts with incredible accuracy. These measurements are super important for many things we use every single day, from navigating with maps on our phones to making sure the internet works smoothly all around the globe. This little planetary hurry is a big scientific mystery. You might be wondering, doesn't the Earth always spin at the same speed? That's a great question. For a very long time we thought it did. We learned that one full spin of the Earth makes one day, which is about 24 hours long. But with our modern technology, we've learned that our planet's rotation isn't perfectly steady. It can speed up or slow down by tiny amounts all the time. Think of it like your own breathing. Most of the time it's steady, but it can get a little faster when you run or a little slower when you sleep. The Earth is a dynamic living planet, and its spin has its own unique rhythm. The reasons for these changes are huge and complex, involving forces both on the surface and deep inside our world. It's like being a detective trying to solve a case where the clues are as big as oceans and as hidden as the planet's core. Scientists believe that several things happening at once are causing this slight summer acceleration. These factors include media group, team of scientists discussing Earth models, Earth core visualization in lab, researchers collaborating with globe at stock at a distribute_equally, the melting of ice at the poles, mysterious movements in the Earth's molten inner core, and even some surprising effects left over from the global pandemic. It's a reminder that everything on our planet is connected in ways we are just beginning to understand. To understand how our planet can change its speed, let's think about an ice skater. Have you ever watched a figure skater spin on the ice? When they start their spin, their arms are stretched out wide, and they turn at a certain speed. But when they want to spin much, much faster, they pull their arms in tight to their body. By bringing their mass closer to the center of their spin, they accelerate. This is a rule in physics called the conservation of angular momentum. And it works for everything that spins, from a top to a dancer to our very own planet Earth. Our planet can act like that figure skater. When mass on Earth moves closer to its center, the axis it spins around, the planet's rotation can speed up. One major way this is happening is due to climate change. As huge glaciers and ice sheets at the North and South Poles melt, that water flows into the oceans and spreads out. This movement of mass from the poles toward the equator is a bit like the skater pulling their arms in. The water, which was once piled up high as ice, is now distributed differently, which can be enough to slightly increase the speed of Earth's spin. But that's not the only piece of the puzzle. Deep beneath our feet, about 1,800 miles down, is the Earth's core. It's made of a solid inner ball of metal and a liquid outer layer. This liquid core is sloshing and swirling around, creating Earth's magnetic field. Scientists think that sometimes these movements can change, creating a kind of friction or pull on the solid parts of the Earth above it. These subtle shifts deep inside our planet can also affect the speed of its rotation, either speeding it up or slowing it down over many years. It's like a secret engine changing gears in the center of our world. There's even a surprising new theory connected to the recent past. During the global pandemic, there was a lot less movement of groundwater. People and industries used less water from underground wells and reservoirs for a while. This means a tiny bit more water weight stayed put in certain places on the continents. Now, as things are getting back to normal, we are pumping more of that groundwater again. This slight redistribution of mass, moving water from underground back up to the surface, could also be contributing to the very small change in our planet's rotational speed. It's amazing how our actions can have planetary scale effects. You might be thinking, if the change is so small, why does it even matter? Well, it matters a lot for our technology. Think about the GPS in your family's car or on a phone. To figure out exactly where you are, GPS satellites need to know the Earth's precise position and the exact time, down to a billionth of a second. If the Earth's rotation speed changes, even by a millisecond, it can throw off these calculations. Over time, these tiny errors could add up and make our navigation systems less accurate. It's not something you'd notice on a trip to the grocery store, but it's critical for airplanes, ships, and scientific research. This is where something called Coordinated Universal Time, or UTC, comes in. This is the official time for the entire world, and it's kept super accurate by hundreds of atomic clocks. These clocks are incredibly precise and don't slow down, but our planet does. For decades, Earth has been gradually slowing down its rotation, mostly due to the pull of the moon. To keep our clocks in sync with the Earth's rotation, scientists have had to add an extra second to our official time every now and then. This is called a leap second, and it's like a little pause to let the Earth catch up. However, because the Earth is now temporarily speeding up, scientists are facing a brand new situation. For the first time ever, they are talking about needing a negative leap second. Instead of adding a second to let a slowing Earth catch up, we might need to subtract a second to keep up with a speeding Earth. This has never been done before, and it's a big challenge for computer systems and networks around the world. Many systems are designed to handle adding a second, but not taking one away. It's a new problem for our super-connected digital world to solve. Thankfully, you don't need to worry about this. The world's top scientists and engineers are working on this problem to make sure everything continues to run smoothly. They are discussing the best way to handle this change, whether it's by introducing a negative leap second or finding another way to adjust our timekeeping systems. It shows how our lives are tied to the planet's behavior in ways we don't always think about. The steady ticking of our clocks depends on the massive, ever-changing spin of the world beneath our feet, and we need to be clever to keep them perfectly aligned. So, is this summer speed up a reason to be scared? Absolutely not. This is a completely natural short-term change. The Earth has been speeding up and slowing down in tiny ways for billions of years. These small variations are part of the normal rhythm of a huge, active planet. The forces causing this, like melting ice, the core's movement and water cycles, are powerful, but they won't knock our planet off balance. It's more like a little wobble in a spinning top than a sign of danger. We are safe, and the Earth will continue its journey around the sun just as it always has. What this teaches us is that our planet is not just a solid, dead rock floating in space. It is a living, breathing system. Everything is connected. The ice at the poles, the water in the oceans, the molten rock deep in the core, and even our own activities on the surface can all influence how the entire planet behaves. It's a beautiful and complex dance of different forces. Studying these tiny changes in Earth's rotation helps scientists understand these connections better and gives us a deeper appreciation for how intricate and delicate our world truly is. It opens up a new window into the inner workings of our home. This fascinating phenomenon is a wonderful reminder to stay curious. There are still so many mysteries about our own planet waiting to be discovered. Who would have thought that melting glaciers and the sloshing of the Earth's core could affect how we tell time? Science is a continuous adventure, always revealing new and surprising things about the universe. Every question we ask and every answer we find leads to even more exciting questions. It encourages us to look at the world around us and wonder how it all works, from the smallest atom to the spin of the entire planet. Ultimately, the news of Earth's faster spin is not a warning, but an invitation. It's an invitation to marvel at the incredible planet we call home. It shows us that Earth is constantly changing, evolving, and responding in ways both big and small. We live on a dynamic world that is full of surprises, and we are lucky enough to have the science and technology to observe these subtle wonders. So, this summer, as you go about your day, you can smile knowing that you are riding on a planet that is, for a little while, in just a tiny bit of a hurry.